Now let's look at part 2 of the worked out problems for projection of solids. So the fourth problem looks like this. That is a pentagonal pyramid. Edge of base 25 mm and height 65 mm is resting on a corner of its base in such a way that the slant edge containing that corner makes an angle of 45 degrees with the HP, and the top view of the axis makes an angle of 30 degree with the XY line. Draw the projections of the pyramid. So let's look at the solution here. So we'll draw the hexagonal pyramid in simple position first. So please note that we have drawn the pyramid in such a way that its corner is on the right hand side, because the question says that it is supposed to lie down as if it is lying on the slant edge. Now it is drawn with the pyramid as if it is sitting on its base with one of the corners to the right hand side. So this is a slanting edge being shown. The sizes are marked, the corners are marked. So here it is being tilted with an angle of 45 degrees with axis. And the lines are projected. And the corners and all the positions are projected, and from the old top view and the new position front view. So where the corresponding points meet will be the next view. So this is done as usual. So the hidden lines are drawn based on visibility. You can see that this edge is hidden. So this corner is hidden. So now the next thing you will have to note is that the most important thing is that when you look at questions, you have to specifically see whether the question says the axis is inclined to either HP or VP, or whether it is the top view of the axis. For example, in this case, axis being inclined to HP, which is 45 degrees, that is coming out as usual. There is nothing great in that area, which is a quite usual thing to do. But when tilting with respect to VP, you have to consider two things: whether you are tilting the top view of the axis or the real true length of the axis. So if the question says it's a true axis which we have to incline with the VP, then the way it has to be solved is slightly different. You have to actually represent the true axis length being inclined at 30 degrees, and based on the true length you have to position your view, because whatever view of axis you are getting in this top view is actually the foreshortened length of the true length of the axis. So if the question says the top view of the axis is inclined, this construction technique is fine. So now the top view of the axis is actually inclined, and then the next step would be projecting from all these corners. And also from this view. So where they meet, you will get the final view here. So we have the view there. And please note the visible and hidden faces. The boundary as usual will be always visible, the boundary edges. And those edges which are away from the viewer will be hidden. But to find that, since this particular edge is completely within this boundary, it has to be a hidden edge. And the other edges which are joining to them also become hidden. So that completes the view. Now let's look at problem number 5, which says the same pentagonal pyramid with the same base and height rests on a corner of its base in such a way that the slant edge containing the corner makes an angle of 45 degrees with HP and 35 degrees with VP. So this looks quite identical with the previous question, but you have to be careful about the subtle change which has happened. In the previous question, it was 30 degrees. It specifically says that the top view of the axis is being tilted at 30 degrees with the VP, but here directly it says that the axis is inclined at 45 degrees with HP and 30 degrees with VP, which means it is a true length of the axis which needs to be considered while tilting. So draw the projections. Let's see how we can solve this. So as usual, we'll be drawing the pentagonal pyramid with the corner. So all the techniques are same until you start drawing the final top view position. So here, please note that this tilting of 45 degrees, here the axis which you get here, the axis position is actually true length of the axis which you get here. So there is no problem in either case. So even though the view of the axis we are taking and tilting it 45 degrees, since the length is a true length of the axis, it is very much okay to use this same way to construct the projection. So here, even though you are tilting the view, you are actually as good as saying that the true length of the axis being tilted, because this length is a true length itself in this view. So that part is right. Now until this point, it is identical to what we have seen in problem number 4. There is no change at all. But when we come to the next stage, there is a difference. So what we will do now, we will draw a reference line first, and from there we draw an angle, draw a line which is actually the true length, which is 65 mm. The true length will be drawn, and that will be drawn at 30 degrees. And then exactly at 65 mm, you will be drawing a locus line. And that the projection length will be marked there. So that gives the orientation here. So that gives this particular line which we have drawn actually is the true length, which is actually inclined at 30 degrees. And based on the theory of projection of lines, if you draw a locus through the true length end, if you draw a locus, and on that locus if you draw another line, that will be the projection. So this is exactly the same theory we are following here. And so that gives in the previous case, this line where we have drawn as 30 degrees, that itself was our view axis location. But here now we have positioned the true axis at 30 degrees, and the projection we have found out by drawing a locus on the across the true length at the other end of the true length, then marking off the actual projection view of the true length there and then projecting it. So actually the view is slightly tilted towards this side compared to the previous case. So that's a difference which we get finally drawing the view. To make this much more clear, I'll try to explain this once again. This line which is drawn here is actually the true length which has been drawn, and which is drawn at the length of 65 mm, and at that line, at that point where it becomes 65 mm, what we do is we draw a locus line like that, and on that locus line what we'll do is we'll take this distance, the actual projected length of the axis that can be taken from the other view. With this point as center, we cut an arc through this locus and join that O to this point to give the current position of the top view. So instead of directly putting the top view as the at 30 degrees, we draw the line representing the true length, mark the true length, and draw a locus at the other end point, and then mark again the projected length of the axis on that, and with respect to that we'll be drawing the solid. So this small change we'll be doing in this kind of problems. And then the next step is straightforward. We simply project it to the top side, towards the front view, and we complete the view as usual. So that gives the final view. So there's a small change in actually the final view compared to the previous case because it is slightly tilted. So now we have come to problem number 6, which is a typical question which comes in exams. That is a square pyramid, base 30 mm side and axis 65 mm. Has a corner of the base on the ground, and the side of the base containing that corner is inclined at 30 degrees to the ground. Draw the projections of the pyramid when the axis is inclined at 60 degrees to VP. So let's see how we solve this. So here, different from the previous cases, we are drawing the top view in the base view we are drawing in the front view, and in the top view we are actually showing the slant side and the slant edge. So we are positioning the part, basically we are positioning the part in such a way, the pyramid in such a way that its base is parallel to the vertical plane. So to make this more clear, we can see, look at the 3D view. So what you see on screen is a square pyramid which is simply resting on its base. So the question specifically says that one of it's resting on a corner, and at the same time one of its base edge containing that corner. For example, if we are going to rest this based on this corner, then the side containing that corner would be, or edge containing that corner would be this one or this one. That is a base side of the base containing that corner could be this one or this one. this edge or this edge. So any of those edges should be tilted with the horizontal plane at an angle of 30 degrees. So this is a question. So let's see how we can go about doing this. So first of all, let's tilt the pyramid at an angle of 30 degrees. So that let's see how it looks like. So you could see that one of the edges has been tilted at an angle of 30 degrees with the vertical plane. And now the interesting thing is that if we try to tilt it with respect to one of the corners, the edge which has been tilted with 30 degrees to the VP will now become inclined at 30 degrees to the HP. So we'll be more clear when we tilt it now. So let's see the tilting. Yeah, this has been tilted now. So the whole solid has been tilted with respect to this corner so that the base becomes parallel to VP, and this edge which has been tilted at an angle of 30 degrees, this edge which has been tilted at an angle of 30 degrees now is also tilted with respect to the HP. So why we are specifically doing this is that only in this view, that is only when the pyramid is made in such a way that the base can be shown in the front view. So if, for example, if you look at the front view, it's very much clear that this particular edge is at an angle of 30 degrees with the horizontal plane, and it is resting on a corner. So that these two conditions have been satisfied. So the side of the base containing this corner, which is either this or this, in this case we are taking this edge, which is at an angle of 30 degrees to HP. So that initial condition is solved. So the next stage would be to tilt this solid with respect to VP at an angle of 60 degrees, so that the axis becomes inclined at 60 degrees, which is quite simple. You simply tilt this solid in this either direction so that this axis becomes tilted with respect to VP, which we can just a straightforward solution. So let's now go back and see how this can be constructed. So as we have seen before, we start with the front view first, so that in the front view we are showing the base of the pyramid as we have seen in the 3D view now. So it is positioned in such a way that you can see the base of the pyramid in the front view, and you project it down and see the slant portion in the vertical side of the pyramid in the top view. So, and you can see that this side has been inclined at an angle of 30 degrees. You can make either this side or this side or this side as 30 degrees. So when we have shown in the actual 3D, we might have actually made this side 30 degrees in the 3D view, but that is fine. So the point is clear. See the edge containing or side containing that corner, any of these edges could be taken as and tilted as at 30 degrees. Now let's see the next stage. So the next stage is simply straightforward. This axis is inclined at simply to the XY line or to the VP. So the axis is inclined at 60 degrees to the VP, and you project upwards towards the front view above the XY line, and from the old front view, project back and get the final projection. You could see that one thing you could imagine now is the base, since it is away, the base will be hidden from view, the front view. These kind of things you should be able to now start imagining, like how the front view is going to be. Since we are looking from this side, these edges and slant faces could be seen. However, the base will be completely hidden from view in the front view at this condition. So you could see that all the boundary edges are marked and made be visible, and the edge which is facing us will also be visible, and edges which are going inside the boundary, they will be hidden. So that completes this view. So we are coming to the last problem in this section. So this is yet another type of problem where a pyramid is hanging from one of its corners, and we are supposed to draw the projection. A square pyramid, 40 mm side of base, is hanging freely from one of its corners of its base with axis parallel to VP. If the height of the pyramid is 75 mm, draw its projections. This is typically quite straightforward in terms of drawing the projections. The only thing you need to keep in mind is where exactly to position the corner and how the whole solid has to be positioned. That is the only thing you need to understand. So let's look at how this can be solved. So one thing you have to know in advance is about the center of gravity of solids. So for a pyramids, for that matter, for any pyramid, the center of gravity lies at h/4 from the base. That is h/4. H is the height. If h is the height of the pyramid, so 1/4 the height of the pyramid from the base will be the center of gravity of a pyramid. So this, many people confuse this with the h/3, which is actually the CG for a plane triangle. The centroid, in fact, it's not CG. The centroid of a plane triangle is actually 1/3 of its height. Please do not confuse this with the center of gravity of a square pyramid. So in the case of square pyramid, it is 1/4 the height from the base. So we position the square pyramids at one of the corner is actually on this side. So since this is a corner which we want to use, one of the corners we need to use, so we tilt it in such a way that we can use this condition, the base condition. And one thing you could notice is this line has been joined. A line has been joined from one of the corners to 1/4 the height, which is the CG, which has been marked as G dash. So the next view, we made this line, that is the line joining the corner and the center of gravity will always be in a straight line while it is hanging freely. So it's a basic principle of physics. So any object when hanging freely will have its center of gravity in line with the point of hanging. So with that theory, we make in such a way that this corner and this center of gravity, in fact any corners you can join, either this corner or this corner you can join. So we've taken this corner. So in the next view, what we basically do is we start drawing the vertical line, and from that vertical line we'll mark off these distances from this side and this side based on these angles which we have here, and complete the square pyramid. To make it much more clear, I can probably show it like that. So if you draw the line joining the corner and the center of gravity like this, the other distances you can mark off. For example, this arc and this arc, this angle and this angle can be marked off this way and this way, and this whole solid can be completed in that manner. And once you complete that solid, it is straightforward. Simply project it down and draw projections from the other top view, and we'll be completing the top view, new top view.